This is figure 13.2 from the book. Now, let's just focus over here for a minute. If we take a sample of seawater in which we have phytoplankton and zooplankton and bacteria and put it in the dark, we have no photosynthesis. So with no photosynthesis, that means all we have is respiration. What should happen to the amount of oxygen in this bottle were we to leave it capped and leave it overnight somewhere? What should happen to the amount of oxygen? Well, if you remember what I just said, the amount of oxygen is going to go down because respiration is going to consume oxygen. Okay, so through the process of organic matter, O2 is used up in respiration. So this dark bottle, this seawater sample that's been put in a bottle that's completely wrapped up or somehow made dark, is an estimate of respiration. So far, so good. Well, if we consider a clear bottle, another sample of water, same sample of water, now we're putting it in a clear bottle into which light can penetrate. What's happening in this bottle? We're getting photosynthesis, of course, because plants now in the presence of light are able to produce oxygen and photosynthesize. But we haven't gotten rid of the respirers. Just like in here, they're still consuming oxygen. So both photosynthesis and respiration are happening at the same time in this clear bottle, what we call the light bottle. That then represents net primary production. It's how much is being produced minus how much is being consumed, and what's left over is the net oxygen, the net primary production. Remember, your net wages. Okay? So this equation that I just showed you, net primary productivity equal GPP minus R, in the dark bottle, we've just measured this quantity. In the light bottle, we've just measured this quantity. And since we have an equation with 3 unknowns on which we've just identified 2 of them, we can then easily find the third. So by rearranging this equation, by adding R to both sides, I'll go back. If we add R to both sides, GPP minus R plus R is GPP equals NPP plus R, which is what we have here. So if we know how much oxygen is produced or consumed, whatever's left over in this bottle, and we add that to how much is consumed in this bottle, we get how much oxygen is produced in the process of photosynthesis. And this is the basis of the light-dark bottle method. Now let's play a couple mind games here. Little thought experiments. What if gross primary production was equal to respiration? What if the rate at which plants were producing oxygen was equal to the rate at which they're using oxygen? So in this case, GPP equals R, or R equals GPP. What's NPP going to be? Well, if NPP plus R equal R, the only thing that makes that equation work out is if NPP is 0, and that's right. You would have no net primary production. Photosynthesis would exactly balance out respiration. The amount of oxygen being produced by the plants would be consumed by the plants and everything else, and net primary productivity would be 0. So NPP would be 0 in that case. What would the situation have to be so that after a certain period of time, say 24 hours, the amount of oxygen goes up? What has to be true for oxygen to rise in this bottle? Well, for that to happen then, this quantity, for that to happen then, for this to become a positive value, respiration has to be lower than photosynthesis. The rate at which oxygen is produced has to be greater than the rate at which it's consumed. And the opposite is going to be true. If oxygen falls in this bottle, then what we know is respiration is occurring faster. The rate at which oxygen is being consumed is faster than the rate at which it's being produced by photosynthesis. So the light-dark bottle method provides us a powerful tool for measuring rates of photosynthesis in the ocean. And here's an example of how it's done. In a typical experiment, a ship will go out and take water samples from a variety of different depths. It will put that water in a light and dark bottle. It will let them incubate over a period of time, typically from dawn to dusk. It might be shorter, or depending on the concentration of phytoplankton in the water column. And then at the end of the experiments, you measure how much oxygen went up in the light bottle, if at all, and how much oxygen went down in the dark bottle. And as it turns out, the difference between those gives us some estimate of photosynthesis. And you can do the math to figure out that that's true. But let's take a look at this example. In the light bottle here, we have plus 4, plus 2.6, plus 1.6, plus 0.8, plus 0.3, minus 0.2, minus 0.5, minus 0.7. So in these bottles, the amount of productivity, the amount of oxygen being produced through photosynthesis was faster than the rate at which it was being consumed. But in these bottles, oxygen was being consumed faster than it was being produced. Let's look at rates of respiration. Here we have minus 2, minus 1.9, minus 1.7, minus 1.6, minus 1.3, minus 1.1, minus 0.9, and minus 0.7. Now, why would you expect respiration to go down? You can understand, hopefully, why photosynthesis decreases as we go deeper in the ocean, because there's less light. But what happens with respiration? As it turns out, respiration is a property for bacteria, which are the major respirers, that depends on temperature. So as it gets colder, everything kind of slows down and rates of respiration get lower. Okay? So if we look then and use the light bottle measurements and the dark bottle measurements to estimate gross primary production, here's what we get. 6, 4.5, 3.3, 2.4, 1.6, 0.9, 0.4, and 0. No photosynthesis at all. What does that mean? Take a look at this one on the very bottom here. The light and dark bottles produce exactly the same result. Well, it's pretty simple. It just means that the light bottle is in the dark. And so there is effectively no difference between the light and dark bottles below this depth. Light has disappeared. The other thing you notice then is that photosynthesis falls off as you go deeper. And of course, it should make some sense to you that photosynthesis falls off as you go deeper in the water column, because light is decreasing as you go deeper in the water column. Okay, so there's a lot to learn by examining these figures and thinking about the processes of photosynthesis that are producing oxygen, respiration that's consuming oxygen, and the light-dark bottle method as a means for estimating photosynthesis.